せていただきます。本日はご多忙のとモハンマド・アブドゥル・ハックさんの学位論文公聴会にご出席いただきましてありがとうございます。私は本日司会務めさせていただきました、新教育病院にあります取締役長でございます。まずは本日の趣旨について簡単に説明をさせていただきます。本学位請求論文は昨年12月18日に、本学システムデザイン研究科教授会において受理されまして、以降、本学西川教授、柴田教授、それから、日本体育大学の角田教授と私4名で審査に当たってまいりました。本日、学内外の皆様に論文内容に関する活発なご聴記事をいただきまして、その結果を学位論文に積極的に反映して完成度の向上を図りたいと思っておりますので、ぜひよろしくお願いいたします。発表に先立ちまして、賀来さんの略歴を簡単にご紹介いたしますと、賀来さんは2020年8月にインドネシアのポリテクニック・エレクトロニカ・ネゲリスラバヤで学士の学位を取得されて、2021年4月に国費留学生として都立大学院システムデザイン研究科電子システム工学域博士前期課程に入学しました。その後、順調に博士国課程に進学いたしまして、現在3年生でございます。これから約45分程度で論文の発表をしていただいて、その後ご質疑ご討論をお願いしたいと思っております。それではよろしくお願いいたします。田中さん、
Good afternoon, everyone. Thank you for attending this presentation. My name is Abdul Haq from Metropolitan. So, in this research, I want to present my PhD dissertation, a study on badminton video analysis based on deep learning models. So, I will go through the outlines. The first is introduction, then literature review, then player detection, subtle detection, racket detection, and dominant area, which is the end is conclusion and future moves. So let's go now to the introduction. In badminton, in the big perspective, there are many things we see or we can research. The first is like the constraint of the badminton, like the rules, the equipment, like this is how many width and the length, and there is a deep philosophy how to make decision making and deep understanding in badminton. The third is the player itself, the player capability, like how the player grip the racket, like the position of the foot and the movement. And the fourth is spatial interaction, which is there is a hitting area or the net play or stage situation. Then the lastly is tactical, which is singles and double has different tactics. In this PhD dissertation, I focus in spatial interaction and tactical. Let's go to this video. Badminton is a fast racket sport with rapid player movement like head speed, subtle motion, and interaction between the player, racket, and shuttlecock. Then the tactical understanding for in double match depends on spatial positioning, like how many players can cover the court and coordination. Even though the computer vision has advanced for video analysis, but in the last 5 years, badminton remains less explored than any other sport. So, the challenge such as shuttlecock small size, very high speed, then the rotation of the racket, which is the racket is very thin, and the complex interaction make analysis very difficult. And many existing methods focus only on isolated detection rather than overall spatial dynamics. The motivation and the study objective of my dissertation is most existing badminton analysis focus on individual detection and doesn't explicitly model the spatial control on the court. So the objective of this study are the first, develop a pipeline for detecting and tracking a players, a shuttlecock, and the racket. Secondly is incorporating oriented racket detection with spatially meaningful representation. Lastly is introducing a dominant area visualization that represents crowd control by integrating the player movement, the shuttlecock position, and the racket information, which has angle information. That's for the introduction. Let's go to the literature review. The first is player detection using faster RCNN. In 2019, Rahman et al. Introduced a badminton player detection, which is using faster RCNN. And it's detected very well, and it's easy for now to detect the person on the field. Secondly, in 2020, Sun from Taiwan made a system which is Tramet V2. It is proposed to detect the shuttlecock from badminton broadcast match, and it consists of UNet based encoder decoder. So if you see here is like a U shape, like this UNet, and this is the encoder in the first, and this is the decoder. Then they use the heat map of the shuttlecock detected, and they also use the temporal information of the badminton match. The third paper or literature review is VIRD. This is the immersive VR-based badminton match analysis that integrates 3D reconstruction from video. So this is enables top-down interactive analysis that support tactical understanding. Anyway, at that time, no one researched about the racket in badminton when making this dissertation. And in the last conclusion of the paper, they also mentioned that a coach suggests adding the racket, which is the racket is no one research about the racket itself. The last literature review is football player dominant region. The player control area analysis was originally developed in the football, basically in around 1990, and there is a researcher with this Caetano and all in 2021 that made a research in the soccer. So this concept provide a foundation for extending player area analysis to other sports, which is badminton. But we still need other information like shuttlecock and the racket to build area analysis for the badminton. We go to the chapter 3, which is player detection. Accurate player detection in badminton videos remains challenging due to the rapid player movement and occlusion when player doing like smash or net play. This factor often lead unstable training behavior and inconsistent detection. To address this problem, this study investigates various training heuristics in the training. So in this chapter, I focus on how I train the model, not in the inference. The objective is to improve training stability and detection progress without modifying the underlying network. This is the pipeline for the player detection. The first is the video input in here and split into image frame. Then we use neural fetching tree. And in here, I modify how I train the model. Then I got the bounding box. Then I need to the ID of every player, so I use the sort for the tracking and player is tracked. Let's go through the first method that I apply. It's normal method to improve the training, which is the cropping, contrast adjustment, or HSV augmentation. It's like data augmentation. This is the example of the contrast changing, normalization, and the other. Secondly, in the YOLO version 3, they use step decay, which is when we use step decay, the training will be just fall, nearly fall. Then it's very hard to get up. So in here, cosine learning rate scheduler adjusts the learning rate during training with cosine. So the learning or the training will be more stable and accurate. This is how cosine doing the training. The third is synchronized batch normalization. So synchronized batch normalization ensure consistent and accurate batch normalization across GPU. If you see in this first video, in the A video, this is a standard batch normalization in YOLO version 3, which is compute statistics separately on each GPU. So this is GPU 1, 2, 3, 4, and it's separately. But in synchronized batch normalization, it shares statistics. This is sigma, statistics across all GPUs. So this makes normalization more stable and improves training. It will be effect when the GPU is very low of RAM, not for the high GPU. Yes. The last method of player detection is image mix. In here, I combine two images into one by blending their pixel. So this makes the training data more diverse and improve detection accuracy. So you can see this is the image mix-up of image 1 and image 2. Let's see the result of all methods that I have done. This is the baseline, which is YOLO version 3. It's trained in couple data sets. The MAP is 33. If we add all the method, we got 37.35 for MAP for player detection. So the cumulative delta is 4.3. So it's very good to improve the MAP 50, 95. Improving this is a little bit difficult rather than MAP 50. That's the quantitative. Let's go to the qualitative. This is the detection of the baseline with various training heuristics. It's detected very well. But there is a problem. How can we know where is the player 1, where is the player 2? So we need to track the player. I use sort for tracking the player. Here is detect and tracking. There is an ID. Player 1, player 2, and player 4. Also from this output, we can get the heat map of the player. This is player. This is the right player. Player 3 and 4. Like how player 3 doing everything in the front of the court, and player 4 is doing in the back. And player 1 and player 2 is left and right. So we can get statistics of every player. Also, we can get the speed for the player, the acceleration of the player for every second, which is this information is needed to get the letter array. In conclusion, the plan detection performance was improved using heuristic training in YOLO version 3. The applied technique is augmentation, image mix-up, synchronize the benchmark, and cosine learning. Then apply soft tracking, then the map increase from 33 to 37. That's for the plan detection. Let's go to the subtotal detection, which is the small things in the badminton and important things. Subtotal detection is challenging, very challenging due to the small size you can see in here, the shuttle arm is straight and it's blurry in motion, which often lead to unstable predictions for the deep learning. Even with the strongest line in trained V2, detection performance can degrade in the fast rallies like smash. So to address this problem, this dissertation in shuttle arm detection will train V2 as a baseline. Then I introduce residual connection and replacing ReLU with leaky ReLU and repositioning batch normalization, which is the aim is to tackle vanishing gradient problem. So let's go to the first method that I have applied, which is the residual connection itself. This is the residual block architecture which is I apply in the baseline. This is the input layer in here, and this is the output. For the badminton, when the shuttlecock is not detected, it will be, we cannot to predict the next frame. So we need to continue the data even the shuttlecock is not detected. So in here, there is the trained data plus by the identity map, which is the real data. So it will be like 50% trained data and 50% untrained data. So the shuttlecock will be smoothly detected. So in the architecture, it looks like this for the unit. I mean the trained V2. This is the residual connection, the red line in here, you can see here. This residual connection will mitigate the gradient vanishing problem and resulting in higher shuttlecock detection performance. And we will see in the result in the later of the conclusion. The second method is M-ReLU or leaky ReLU. So the shuttlecock is small, fast, and often appears faint or blue like the first image. ReLU, rectified LU, is suppressed negative activation, which can remove weak but important feature. So, for example, the detection of shuttlecock is the system cannot detect the shuttlecock, but we need to continue the shuttlecock because shuttlecock is continuously moving. So, rather than we stop the detection or training, we still continue the small number of the data training. So with leaky ReLU, it can be very important to detect the small continuously moving part, which is subtle. And this is how I apply the leaky ReLU in here. Sorry, this is so small. In here, this is leaky ReLU. This is in the encoder, and this is in the decoder. Last method is post-residual batch normalization. Batch normalization, when it plays in the early of network, it can be over-normalized, which is could degrade the shuttlecock detection performance. Then, by applying batch normalization after or in the last of the neural network, it can be normalized, not over-normalized. So in here, after the residual connection, which is this is the loop, this is the addition in here, post-addition batch normalization, even in the encoder or decoder. Then the dataset that we use is the trained V2 dataset, which is from broadcast match videos. And let's see the result between the baseline and the proposed method. The left part is the baseline. You can see this is not normal detection because this is not part of the game in here, but it's detect on the baseline. But in this proposed method, I can detect the shuttlecock very well. But if this is too small, I can zoom it, so we can track how the shuttlecock is detected. So this is how it is. So how about the shuttlecock is moving in the slow, like net play, doing the net play in the center of the court? This is the result of doing the net play. This is a net play. It should detect very well. Then the most difficult part is the smash. The smash is the shuttlecock is very fast and have a blur in the motion. So let's see. This is what the plane doing the smash. So that's a qualitative result of the shuttlecock detection. So how about the training loss? The training loss is better than the baseline, which is the green is the baseline and the blue is the all method applied, which is very low for the loss. Because the loss is very low, there is an improvement in precision, recall, F1 and accuracy, like 84 to 88 and 75 to 78. So in conclusion, the shuttlecock detection accuracy was improved by extending the baseline, which is running V2, using residual learning and leaky ReLU to mitigate the dying ReLU problem, and to tackle over normalize with post residual. Then we can see the improvement of the model. So that's for the shuttlecock detection. The next research is the racket detection. Why racket matter? The racket defines the effective interactive point between player and shuttlecock, right? In the neck play, for example, neck play, small change in the racket position strongly affects shuttlecock. So racket orientation reflects intention, timing, and shot rate. For example, in the figure in here, the position of the racket is effect on the outcome. Is it net play, or is this clear? Is clear block? So racket detection in badminton videos is challenging due to the lack of publicly available data. So when I'm doing this research, there is no available data sets for the market. Existing data sets focus on player or shuttlecock, making racket detection analysis difficult to perform. So to address this problem, this chapter construct a dedicated badminton racket data sets with oriented multi-box annotation, which is rectangle. Then the racket detection is conducted in yellow section 11, ODB, and short for the. This is the statistics of the data set that I have made. We call ORDB, Oriented Racket Database. This is composed of total like 8,000 images taken from double badminton video match, carefully curated and annotated using the CPA. And this annotation have rotated polygons. So there are 45 rallies that we have annotated. How we annotate? We annotate the racket using CPIP. CPIP is the tools, annotation tool from Facebook right now. We annotate manually, one by one. There is an ID for every racket. So hopefully this dataset will be impactful for the badminton research analysis. the statistics of the width and the height. So this figure shows the size distribution of racket bonding blocks. Most rackets have a similar width, but smaller number appear wider due to the camera angle. Camera angle is affected. Then the height value are more consistent in here. So when the racket length is relatively stable. And this is the angle or orientation of the racket. The racket appears at many different angles in here. Some angle occur more frequently in here. It is because the serve position or ready position. And how I detect the racket, we use the Euro version 11, which has oriented object detection. Because the Euro version 12, there is no oriented object detection, so I use the Euro version 11. After I tried the dataset, this is the detected racket. It's detected very well, even the racket is very thin. It is very thin, it's very difficult. And it detects all four rackets. Then how we can know the ID of the racket? We can use the short tracking. This is still thin, maybe you cannot see clearly. This is the track of the racket. In conclusion, racket detection was advanced through the introduction of novel datasets, which is ORDB. And ORDB involved oriented body blocks to model the pose and enabling location aware using the location element. Then apply sort tracking to get the ID of the racket. That's all for the detection, which is player, sample pop, and the racket. And the last is the chapter 6, dominant area. In double match, performance depends on how effectively the pair control and share code rather than on individual skills alone. If you see this figure, this is the example of miscoordination or miscommunication of double match. So sometimes the player one hit the second player racket. So it happens sometimes, even in the professional. So rapid role switching during rallies require coordinate positioning to cover open area like front or the back, left or the right. This study, dominant area, addressed this problem by introducing a visualization which is dominant area that estimates the court regions reachable by each player, not by the team, but each player. Which is use the player, shuttlecock, and the racket information. So the dominant area represents which player can reach a region of the court. So it lies in the first page of the introduction, which is spatial and tactical. In here, this is also the example how is coordination or is communication happen even in professional. How I made the dominant area? So I incorporate the result of the player detection, which is the location of the player itself, then the shuttlecock location, which is X and Y, then the racket X, Y, and theta, or the angle of the racket. Using Voronoi diagram, we can get the area of the range of the double, like this. I apply double point in here, like 1, 2, 3, 4. If we zoom, it goes like this. Every player has its own area, like this. area, and in double, left and right, it's for defensive, and the front and back is for attacking or pressure. And by the way, in this rally, the right team is the winner in this rally. Let's get to the statistics of the dominant area. This is the individual dominant area, which is the green is a higher area statistic. And if we summarize of the team, the right team is has more dominant area, which is the winner of the rally. So in conclusion, the proposed contribution delivered dominant area estimation by integrating the player, the shuttlecock, and rocket information, which is also the angle of the area. So the visualization reveals static or region of the area in double. And this approach aligns with sports science concept of anticipation or effective or coverage. That's for the chapter 6. We go to the chapter 7, which is conclusion of all research and what is the future works. A short survey was conducted to evaluate the clarity of is it useful or not, this research. So participants read short rally videos and based on player position, shuttlecock movement, racket direction, and dominant area, and represent using 1 until 10 scale. Let's see how many participants that participate in the survey. There are 57 response. The first is from badminton club in Tachikawa, which is I joined in the badminton club. Then the badminton club in Thailand in the Bangkok, and in Indonesia in Jakarta. Mostly the participant is like play doubles, and like 50% of the participants doing the badminton more than 5 years. This is the result of the rating scale from 1 until 10. Player detection and shuttlecock detection is a very high score, like 9 out of 10. Then the racket detection shows greater variability and the dominant area, which is 8, but it's still good out of 10. In conclusion of all research, this dissertation established a complete outline of badminton score analysis, player detection, shuttlecock trajectory estimation, racket detection with the angle, and dominant area estimation. I want to say again that player detection was improved through heuristic below trajectory training and using SOP for the tracking. Then shuttlecock detection was enhanced by extended track activity as a baseline with residual learning to mitigate vanishing gradient and leaky value to avoid the guiding rally problem, and post-residual basic normalization to prevent over normalization. Then racket detection was applied by creating novel datasets we call RDB with oriented bounding blocks and performed with utilization 11 OBP and tracking with SORM. Together, this contribution delivered a dominant area estimation on visualization with all data placed together. And we have seen the user evaluation. Results show the 9 out of 10 for player and shuttlecock detection, and 8 out of 10 for racket detection and dominant area. So it's positive. How about future works? There are still many that can be researched in this dominant area analysis or the other. The future works focus on improving dominant area by considering temporal factor such as the delay, the reaction delay of the player, and interaction between the player to the shuttlecock natural movement. So shuttlecock natural movement is very hard how the shuttlecock is moved. Then the framework can be extended to analyze tactical behavior of the player, especially in the double player. So by examining like front and back hold or left and right. In sports science perspective, future work can integrate like teach the tyrant of the player and player coordination dynamics. So that's the future work of this research. In here, I want to show the publication of me doing this research. It is around 30 publication with this 2 journal and some international conference, which is the last conference held in Japan. And that's all for my presentation. Thank you so much for today.
ありがとうございます。Are there any questions? So, yeah, I think that his research consists of the fundamental detection model, so improving the conventional method. And then he wants to use the detection result to high-level analysis of the badminton play. So he proposed the dominant area using the player position, player movement, speed, and racket position and direction. So I hope that I want to analyze the player performance, play quality, and strategy goodness. So maybe he is going to do such a high-level analysis of the play game. So yeah, and today, so we want to have a lot of discussion. So if the question or comment, please. Is there any comments?
Thank you very much for the invitation. So I'd like to ask about future works. You mentioned so there are lots of things to develop this research. So would you explain about the second point? So the framework can be extended to analyze tactical behavior. So what is needed to improve to develop in this point?
Thank you for the question. So the point is the analyze tactical behavior. The meaning of the future work in this point is how the behavior for every player. For example, in badminton, in every region, it has many types. For example, Japan national team is like doing a defense in the badminton. Even there is no data show, but the badminton fans see that Japan has a defensive. And for the South Asia is like Indonesia, Malaysia, Thailand is always having an attack. So that's tactical behavior that we can do the research for this research. So we know that how behavior of this team like Japanese or Indonesia or the Thailand. So that's
Is for that to develop in that direction. So you maybe you don't need to develop not other detection methods are not required to develop those analysis. Do you think?
So in the dominant area, there is no deep learning, but in the future one, we can use the LLM or the
LLM to develop the tactical behavior analysis.
Because this is still the baseline for the area analysis, so it can be developed using the deep learning models.
Yes, thank you. Thank you very much for the presentation. I have one question. So, your domain area moving is very smooth. This so maybe quality is good or more high accurate or high speed accurate. How about this quality?
Thank you for the question. This is also my problem when evaluating the visual representation, because there is no ground truth. So that's why I make a survey to get the evaluation. Is it useful or not from the badminton amateur? So it's still, I still have a difficulty to evaluate by the number. Is it good or not? So that's why I use this tool.
Thank you.
すみません、日本語で恐縮ですが、ちょっと今、運転中でちゃんと、ディスカッションできないんですが、チャットに質問を3点ほど書かせていただきました。日本語で申し訳ないんですが、ちょっと、質問していただけますでしょうか。
ありがとうございます。じゃあ、ちょっと待ってください。You use the deep neural network, so can you use the common filter or classical method? Can you compare the accuracy of the deep neural network and the classical common filter or processing method? Which is better? Which is better? Hi.
Thank you for the question. So here I want to answer. If we want to compare like Kalman filter with the detection itself, I think in this I want to show me the subtle detection. The baseline of this detection is the Tramet V2, which is as a baseline. And this baseline has a filter like Kalman filter. So I think we cannot compare Kalman filter with the deep learning model because it's working together in the baseline. So in here, Kalman filter like conventional method with the deep learning model.
So does this method employ the posterior information or temporal information propagation?
Position.
No. So Kalman filter is the posterior information, and the posterior information is forwarded to the prior and propagate the information. Is this method your method? So in your method, such a posterior information
Of course. Yeah, there is.
is used.
There is. Yeah, there is. Because
How to use?
it's the baseline. So we use the previous frame, previous detection to detect the post detection.
But this method is called as detection, tracking by detection.
It's detection. But
Not tracking.
yeah, tracking.
Tracking by detection.
It's in the baseline. So
Next frame expectation is done.
yeah. But with the detection itself, it can more accurate. The temporal information is in the first layer. In the, I want to show this. In here, it's temporal.
Yeah, but the question is, which is better for the deep learning method, the method and the convolutional method?
If I can say by the research last year, the deep learning model is better.
Yeah.
Yeah, but I cannot show the data because I didn't write this. But deep learning model is better than the conventional.
じゃあ、セカンドクエスチョン。実はすみません、ちょっと中途半端ですけど、そんな感じで結構。で、セカンドクエスチョンは、your research is the top view image. So for the back view image, the method can do the good performance for the back view image.
So for the back view, it's very difficult to get the data of the back layer. So in here, I decided to use the top view videos. So if this system applied the back view, it's not that good for the top view. So there is a limitation.
Can you apply your method to the back view image?
That's possible, but for the rocket, it's very hard to detect. Yeah, because the trained data is in the top view. So if you want to track the data of the back view, we need to train. But in my time of the research, annotation in the back view, like I need to show what is the back view. This is the back view. When we are annotating in the backside, it's very hard to train, and the inference is very worse. So that's still the problem in the fundamental research analysis.
By deep learning method, so I hope that the size over the picture. Small size, large size, all size can be treated. Such a deep learning method is required.
It must be.
To also you have to use the amount out of lot of data.
That's right. It's the
Small
data.
rocket, light rocket.
Yeah, the training data must be done.
Third question, so did you apply your method to the other resemble traits? So for example, tennis, table tennis. So someone say that especially for the tennis research, so the research is very progressive and there are many good methods. So, can you apply your method to the school of tennis?
Thank you for the question. If I can answer this method, especially this method, is possible only for the badminton. So it cannot be applied in the other sport because badminton has its own characteristic. It cannot be changed like table tennis.
So, if you discuss
when I'm doing the research of table tennis and tennis is many members. So in here I want to start the research.
special improvement for the badminton play.
So in this dominant area, I start from the reading this paper. This is the soccer play using forearm diagram. Many research doing this, but no one doing research in the badminton. But when I apply this system to the soccer, to the badminton, it's not that simple because it's only player detection in here. It's only player location. But in badminton, there are many aspects like the racket and the soccer ball. So that's why I made this area estimation.
I think that the different area analysis can be applied to the doubles tennis game.
Possible. It's possible. It's possible. But we need to. The harder part of this is evaluation. So for the tennis player, this is good or not. So the test will be this.
はいはい、すみません、あまりちょっと今できなくて、Thank you very much for interesting discussion. どうもありがとうございました。
ありがとうございました。突然すいません。お願いいたします。
これまだ途中の段階ですけど、論文の方でもいいんです。
はい、はい、
ちょっと座りながらお願いします。It is my great honor and pleasure to have been given the opportunity to attend your lecture. My name is Kakuta from NSSU. I'd like to ask a question from the perspective of the applied aspect of your research, especially from the viewpoint of sports science. First, to provide context for my question, I'd like to outline what I understood from your presentation. I would be most grateful if you could kindly provide a clear response, including any necessary future explanation, if any of my question contain any misunderstandings. You are concluding research primarily focused on developing analysis system for badminton match image. The four outputs from the analysis system and the development are all highly variable in badminton analysis. I can state with confidence that these four of information are essential based on my past experience serving as a member of Japan Olympic Committee's for top athlete performance improvement team. Among many aspects for your research that interesting me, today I would like to focus primarily on figure 6.6 speed statistics.
From today's presentation, I well understood the importance of speed analysis. Could you explain in a little more detail your thought on how this analysis is being utilized to support badminton players, including its potential applications?
Thank you for the question. So in Abdul Sensei's question, there are 3 points, which is the first is the future work in sports science perspective, and then how I use the speed statistics in dominant area, and the lastly is potential application. So in the future work of sports science, this research can be incorporate in sports science using like this. How tired the player can affect the area. Like if the player is very tired, the area must be more small than the player that have high stamina. Also, the shuttlecock natural movement. So this is the research that, still I didn't find any research. Which is shuttlecock has own characteristic using the feathers for the component. So there is a physics in there. It can be future work to incorporating the dominant area. Then the speed statistics in the dominant area. In dominant area, I apply speed statistics. When the player speed is high, the dominant area will be smaller. Why? Because when the player is running, for example, we are running. At some point, we got tired, like we get hard to get back to the position. So this is how I use the speed statistics. So when the player is not running or running slow, the area will be larger. And the potential application is for coaching. So I hope this research can be like a baseline for other researcher to doing the coaching or athletic information. So that's my answer. I think it's translated well.
Thank you for your very clear explanation. Now I have a much deeper understanding of the importance of the research. Having heard your explanation, I have one more question. I know you are aware that players required energy, used stamina, to sustain their performance throughout a match. Is it possible to derive information about players' energy performance? Click 6.6 in Dr. Sis's page 94. Page 94.
So 60. The
Yes. But in this context, energy means information related to factors such as calorie consumption. For example, in marathon running, this would be time and the distance run up to the point.
So thank you for the question explanation. So this statistics explain how fast the player can reach in every frame, for every frame. So not for the like running this point to that point, but this is for every frame. So in here, this is for example 73 frame, then this is 74, then this is 75 frame. So basically in here, this player doing movement faster. Here. So that's for the speed statistics. But in here only speed. So that's my answer.
Okay. Thank you very much. I think regarding my question, I understand simply that the integral values of the wave represent distance. Is it understanding correct?
So this is not the distance.
I understand simply that the integral value sigma of wavefront represent distance. Is this my understanding correct or not?
For this image.
Wavefront, wave.
Wave.
The integral of the waveform.
Oh, yes. It's a speed. No, this is not distance. Yeah, it's possible. Yes, it's possible to get the distance because it's a better information.
Okay, thank you very much.
Sorry, that's weird.
何かはいはい
So, Haki-san, according to slide number 65, your second point, let's say if I have to train the model and I don't know about the game, so what tactical behavior we need to observe in the double player as you have also played by yourself? What behavior you have choose, and in vice versa, what other team has applied or which techniques they have used? Could you tell me the features which I could simply embed into some model?
So for the tactical behavior, if you want to do training, the things that we need to know is we want to know is it defense or the attack? I think I can say the simple as is it attack or defense? So the other team can know what is the type of the enemy team. Is it defensive team or the attack? So that's the.
And just like before you said, are these techniques different if we are playing from the Japan, from Indonesia, and from Thailand? And how we observe all tactical behaviors from the player and create one model?
It's possible to make the model like that. So we want to know the difference between the mentioned model. So it's possible to like a future model for the tactical behavior.
And could you please give one or two examples in front and backboard of the features? One or two examples of the features.
behind the backcourt is applying. This is like a more high tactical analysis. It must be incorporating the author from the sports science. It will be incorporating like if the player in the front, what is the possible shoot, then the player must do. Like, is it possible doing the smash in the front, or is it possible in the back? So it is like suggestion on the player.
Thank you so much for your question.
Thank you for the question.
All right, are there any questions? Okay, please. Sorry.
Okay, thank you so much for the opportunity. So first of all, thanks for your presentation. It's a very interesting presentation, and I'm interesting about the dominant players. So in your presentation, in the dominant area in the chapter 6 result, yes, you see, you saw that the right team, the blue and red team, there is some white space. I'm curious, is it the player coverage area? So the white is mean the player is possibly will not cover the area. This is my first question, and the second one is how if it's implemented in the single match, not a double match. Are the dominant area will be shrink, so we'll know that which area will not cover best for the player, or it will be look the same. I think that's all. Thank you so much.
Thank you for your question. There are two questions. I will answer the first question. What is the white thing? So this is the area that's right. That this is the area that the player is hard to reach. Not impossible, but hard to reach. Yeah. So the larger the area, so more the worse of the team of the dominant area. And we can get the conclusion in the next chapter. Anyway, in the rally, the left team is I cannot say the loser, I mean, the right team is the winner. So in here, there is a space. This is a white space. This is the white space. So yeah, that's the answer. And the second question, how about single game? So this is the first motivation how I made this research. Many researchers research about single, so no one touched the double. Not no one, but little research about a double. So that's why I did the double test. But how if this system apply in the single? In my opinion, it can be applied, but it will be very hard to get the area right. I think for the single, it must be like around run, not the this floor. Because the divider is not as much as like double. So that's in my opinion for the single. Thank you.
Haki-san, thank you for your presentation. I have a detailed question. I think when the player is shooting the shuttlecock is so fast. When in your page 13.6, yes, when the player is shooting the shuttlecock, the speeder is more faster than this page. I want to know you how to fix this problem, or your solution is like this.
So, thank you for the
Yes.
question. So, yeah, the shuttlecock is very fast and there is some motion in here because I use the baseline of the front end. They incorporating the heat map. So in here it very well even the image of shuttlecock is not round but it's like a line. And because in this deep learning has a temporal information like previous information, so it can detect very well in here. So it because the temporal information.
Okay, I know. Thank you very much.
For the question.
Are there any?
So I have a question about chapter 4 and 5. You mentioned that blurring the shuttlecock or rocket makes tracking difficult. But I think the blurring has different color settings. So if you use the high frame rate camera settings, capture fast shuttlecock more accurately, but with lower quality camera, the blurring should be larger. Can you propose model hunt this difference or not?
Thank you for the question. So, honestly, this system, if we apply in like 480 pixel, it's still hard to detect. But in here, we have 2K videos, so it's detectable. So, yeah, I can say that it's a limitation of this system. If we apply in the low resolution and low FPS. By the way, this is 24 FPS, not like 60 FPS, and it's regular. So that's my answer for the like frame rate or quality of the image. This is the answer.
Thank you for answer.
Okay, thank you so much for the interesting talk. I just wondering, my first question is why you only use the top field camera compared to the front camera? Because in my opinion, if we use in the front camera, we are not only get the strategy or the all of the game plan, but also we can get the human body movement that maybe we can also evaluate in the future. Like how can we improve the skills of the persons when doing the badminton and so on. Maybe for this approach, it is good for the referee or good for the coach that look at the games. But when we look at the performance of the players, maybe we need another camera that can get more data like the humans movement and so on. Okay, thank you so much. What do you think about that?
Thank you for the interesting question. It's a deep question about how badminton play. the focus on this dissertation is the area and double match. In the early time of I doing this dissertation, I researched in the backfield of the video, but the player in the back is very hard to detect. I have tried doing the training like rocket detection, but it's for example, the net is occlusion, has big occlusion for the rocket. So I can say it's a little bit hard to detect the condition of the back player. So from that problem, I decided to use the top view video. Then the focus is in the tactical and analysis. Because in the player analysis, like the pose, it will be another research, but it can be incorporated to the dominant area analysis. That's my
Yeah, I think I just give some suggestion because this video is the real video that we can watch in televisions or in YouTube and other platforms. So I think in the futures from this video, all of the people can get the information about the person's skills. Maybe if you look at the soccer players, after the soccer games, we get the score of each player. So that for the soccer soccer coach, they also evaluate for this player. Maybe I just can give recommendation for this one. Okay, thank you for interesting talk. Yeah.
Thank you for the suggestion.
I think that if you want to analyze the back here, can you zoom up the image and so removing the blur? So
It's depend on the quality of the image. But with the AI rapidness, I think it can be possible in the next. That's good.
I also think that you have to use the image to recognize the player, for example, kind of shot,
Yes.
both or
Right.
so that's a very important information
Yes, that's right.
to evaluate the player performance or okay. Are there any questions?
Thank you for this opportunity. My name is Zikri. I'm a master student. In chapter 6, in dominant area, you are using Voronoi diagrams, right? I see in this slide, you use dummy point at the outer, at the edge of the Voronoi diagrams. I think the length of the dummy point to the center of the field of the game, it's so much affected the area of Voronoi diagrams. How you define the length of the dummy point from the center of the field? Yeah, thank you.
So, as the name is dummy point, basically there is no reference how I make this dummy point, but this is like is it good or not? This is by my point of view. So it's like the number of the dummy point.
So maybe one more question. So why you choose Voronoi diagrams for dominant area? Why not using like tracking player trajectory or something like that? What is the advantage of using this one? The advantage of using Voronoi diagrams. Yeah.
So there are many methods to use the area. I have in the first I try to using the circle, but it's not that good in my point of view. And for the trajectory is the input for the dominant area itself. And in many searching how sport area analysis like soccer and the other, many research doing use the diagram. And at the time, right now, no one talking about Corona diagram in Pakistan. So that's it. Because all the sport doing like Corona diagram.
So currently, what is the distance, the number, the dummy point to the field? What value you use right now?
So it's there is no calculation to put the dummy point. So in this system,
I think there is two lines, right? You can use Corona diagram right now because there is a dummy point. So currently, what is the length you use in your thesis right now?
So the length of the dummy point, there is no reference. There is no reference. So it's just the point, but it affects the dominant area.
So any number is okay.
It's a pixel.
It's a pixel.
Yeah, it's a pixel. So it's not in the distance, but it's in the pixel. So after the detection, we get the pixel number. Then we use the pixel number to generate the dominant area.
Oh yeah. I see. Thank you very much.
I'm sorry, I can't understand. How to determine the distance between the dummy point?
There is no reference. There is no reference.
So,
It's like that.
okay, if you change the dummy point, so the Corona diagram is also change.
Yes. Change.
How can I determine the
Because there is no baseline and there is no reference point to make this. So there is no reference point.
you define?
Divine.
They are very difficult. So the relation between the dominant area and the so-called control area. Control area means can hit or cannot hit. So are there any quantification? You select the dominant area. Are there any questions?
Hudson, so you are doing the video analysis, but when you annotate your data set, the data set you annotated is frame by frame. So how your model utilize the interframe temporal informations?
In all video.
Yeah.
Oh, okay. So I will show you so in here, in detection, I use sort tracking. This is 2016 old method. With using sort, we can know the ID of the layer. In the bracket, there is an ID. But for the Shutterstock, we don't need the tracking of sort because it's tracking. So that's how I got the temporal information.
So you also tracking the player identities during the video.
Yes.
Oh, thank you so much.
So you said that the Shutterstock is on one. Are there any cases? So but your case, totally four players. It's not so difficult. For example, football,
Yes.
basketball, there are many players. So sometimes misprint in the film.
Position of frame.
Yeah. Thank you very much for.
Thank you very much for your presentation. I'm very enjoy your presentation, especially it's about sports science. So I'm a bit interested with your shuttlecock detection. So in this case, you are trying to improve the performance of shuttlecock detection by changing the activation function using liquid ReLU and then using residual network. But in this video, I think, especially previously you mentioned about the temporal information, and then I saw that when the shuttlecock on the ground, so the model could not detect the shuttlecock well, and then when the shuttlecock on the air, and then like maybe in this case, like the front side of shuttlecock is on the bottom side and then the feeder on the top side, so the model could not detect the shuttlecock well. Is the issue on the imbalance between the data set on the shuttlecock, or is it because it's too overfit from the model according to data set? So I would like to know about that.
Is it like the position of the shuttlecock?
Yes, it's maybe if the front side of shuttlecock is on the downside, so it could not be detected with your model. And then when the shuttlecock is on the ground, in some cases the model could not detect the object. Is that caused by the overfit or just imbalance between the negative and the positive of detect shuttlecock?
In my opinion, it's about temporal. Temporal. So this deep learning model use the temporal for the main feature. So if there is no temporal information, it will be not detect. Like that.
Okay. Thank you very much.
Thank you very much. Many constructive comments. Thank you very much for very, very constructive and important comments. So I suggested Haq-san to improve the processes based on today's comments, questions. Okay. And so I hope that Haq-san in future analyze the clear performance or free quality using the upload image. So I want to close this public presentation. Thank you very much for attendance. So many busy persons. Thank you very much. And thank you for Haq-san. Thank you again. じゃあ、最後先生、少しね、すみません。角田先生も少しね。じゃあ、ありがとうございました。終了にいたします。Thank you very much for attending.